You can take it away, Lageera.
So, hi everyone, welcome to my presentation on the wonders of the matrix. So, what is a matrix? In mathematics, a matrix is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns, which is used to represent a mathematical object or a property of such an object. So, matrices are subject to standard operations such as addition and multiplication. A field of F is a rectangular array of elements of F. The numbers, symbols, or expressions in the matrix are called its entries or its elements. The horizontal and vertical lines of entries in a matrix are called rows and columns. So here are just examples of how a matrix would look like. So the size. The size of a matrix is defined by the number of rows and columns it contains. There is no limit to the number of rows and columns a matrix, in the usual sense, can have as long as they are positive integers. A matrix with m rows and n columns is called an m times n matrix, or an m by n matrix, while m and n are called its dimensions. For example, the matrix A above is a 3 by 2 matrix. So matrices with a single row are called row vectors, and those with a single column are called column vectors. A matrix with the same number of rows and columns is called a square matrix. A matrix with an infinite number of rows or columns, or both, is called an infinite matrix. In some contexts, such as computer algebra programs, it is useful to consider a matrix with no rows or no columns, which is called an empty matrix. So where or how do matrices come to be? So matrices have a long history of applications in solving linear equations, but they were known as arrays until the 1800s. The Chinese text, The Nine Chapters on the Mathematical Art, was written in the 10th to 2nd century BCE, which is an example of the first use of array methods to solve equations, including the concepts of determinants. In 1545, Italian mathematician Girolamo introduced the method to Europe when he published Ars Magna. The Japanese mathematician Seki used the same array methods to solve equations in 1683. The Dutch mathematician Jan represented transformations using arrays in his 1659 book, Elements of Curves. Between 1700s and the 1710s, Gottfried publicized the use of arrays for recording informations or solutions and experimented with over 50 different systems of arrays. So Kramer presented his rule in 1750. The term matrix, Latin for womb and derived from mater, mother, was coined by James Joseph in 1850, who understood a matrix as an object giving rise to several determinants, today called minors, that is to say, determinants of smaller matrices that derive from the original one by removing columns and rows. Author Cayley published a paper on geometric transformations using matrices that were not dot-noted versions of the coefficients being investigated, as had previously been done. Instead, he defined operations such as addition, subtraction, multiplication, and division as transformations of those matrices and showed the associative and distributive properties held true. Cayley investigated and demonstrated the non-computative property of matrix multiplication as well as the property of matrix addition. In 1858, Cayley published his A memoir on the theory of matrices. in which he proposed and demonstrated the Cayley-Hamilton theorem. So the rules. Algebra of matrix is the branch of mathematics which deals with the vector spaces between different dimensions. The innovation of matrix algebra came into existence because of the n-dimensional planes present in our coordinate space. This arrangement is done in horizontal rows and vertical columns, having an order of numbers of rows times number of columns. Every pair of points in a three-dimensional space represent a unique equation with one or more than one solution. The basic idea, or the central idea of applied mathematics, revolves around linear algebra. For instance, by reliving the rules and regulations, we get into a generalization of vector space, which by calculus leads to the solution of differential equations. So here we can just see some of the rules of matrix algebra. The algebra of matrix follows some rules of addition and multiplication. Let us consider A, B, and C are three different square matrices. A is the transpose, and A, -1, is the inverse of A. I is the identity matrix, and R is the real number. Now, as per the rules of laws of matrix, A plus B is equal to B plus A, which is a commutative law of addition. A plus B plus C is equal to A plus B plus C, which is equal to A plus B plus C, which is the associative law of addition. ABC is equal to A times BC, which is equal to AB times C, which is the associative law of multiplication. A B plus C is equal to AB plus AC, which is the distributive law of matrix algebra, and RA plus B is equal to RA plus RB. We can also see below that the transposition of matrix. And below that, we can see the inverse rules of matrix, which is as follows. So let's now take a closer look at adding and subtracting. So adding. To add two matrix, add the numbers in the matching positions. These are the calculations for the matrices above. So 3 plus 4 is equal to 7. 8 plus 0 is 8. 4 plus 1 is equal to 5. And 6 minus 9 is equal to -3. The true matrices must be the same size, and the rows must match in size, and the columns must match in size. So as for the example, a matrix with 3 rows and 5 columns can be added to another matrix of 3 rows and 5 columns. But it cannot be added to a matrix with 3 rows and 4 columns because the columns don't match in size. Now looking at a negative. So for the negative, it's quite simple, as all we do is apply the negative sign before one of the matrices. So the calculations for the diagram above would be -2, which would equal also to -2, and then you'd have negative and have brackets of 7, which would equal -7, and then negative, and then you times it by -4 would equal +4, and then -10 would also equal to -10. So now looking at subtracting. To subtract two matrix, subtract the numbers in the matching positions. So the calculations for this one would be 3 minus 4, which is -1. 4 minus 1 would equal 3. 8 minus 0 would equal 8. And 6 minus -9 would equal 15. So note that for subtracting, it's actually defined as the addition of negative matrix, which is equal to A plus -B. So now let's look at notation. So a matrix is usually shown by a capital letter, such as A or B. Each entry and our element is shown by a lowercase letter with the subscript of a row or column, as you can see below. So which is the row and which is the column? Just as a review, rows go left to right and columns go up to down. To remember that rows comes before columns, you can use ARC, which is A, and then R stands for rows and C stands for columns. So this is just an example of how to apply notation. So for B1, comma 1 would equal 6 because the entry at row 1 and column 1 is 6. And then B1, comma 3 would equal 24 because the entry at row 1, column 3 is 24. And then B2, comma 3 would equal 8 because the entry at row 2 and column 3 is 8. So now let's try some problems. So I've put up a problem on the screen. Feel free to try it out and type your answers into the chat. I'll give you guys a few seconds to complete it. So the answer for this matrix problem would be B, because to add two matrix, just add the numbers in the matching position. So the calculations for this question would be 2 plus -1, which is equal to 1, -4 plus 3, which is equal to -1, -3 plus -5, which is equal to -8, and 2 plus -2, which is equal to 0. So now let's try a subtraction problem. Again, I'll give you like a couple of seconds to finish it up before I reveal the answer. So the answer to this problem would be as the calculation as follows. To solve this particular problem, you'd have to subtract the two matrices. Just subtract the numbers in the matching positions, just as it follows. So 2 minus -1 is equal to 3, -4 minus 3 is equal to -7, -3 minus -5 is equal to 2, and 2 minus -2 is equal to 4. So now let's look on how a matrix connects to our daily lives, because in reality we do use matrices a lot, we just don't realize that we use it. The application of matrix. So these are just a couple of examples of how we apply matrices in most of our daily careers. Business and economy, so it's measurable values used to display overall performances. Data and statistics, representation methods for plotting the common survey things. Geology, used for making seismic surveys. And robotics, basic components for the robotic movement. So matrix in business. So we use matrices for linear programming to determine the most profitable combination of ingredients in a product, and then calculating commissions, bonuses, special pay, interest costs for loans and financing, and insurance liability and cost. And three, we even use it to look at an analysis of how the business is going and maybe upcoming risks. So matrix in geology. So we use matrices in geology for a couple of things. So you use it for the definition and arithmetic of n-dimensional matrices, which are studied and proved. The cubic matrix is a special case of n-dimensional matrix. And you also use it for a multi-dimensional data, which is expressed as a brief of theoretical analysis, and also is good for looking at the exploration and forecasting and weather. Matrix in data. So we use matrices in statistics as it's a design of matrix, which is also known as a model matrix or a regressor matrix, which is a matrix of values and exploratory variables of a set of objects often denoted by X. Each row represents an individual object with the successive columns corresponding to the variables and their specific values for that object. And three, the design matrix contains data on the independent variables in statistical models which attempt to explain observed data on a response variable in terms of the exploratory variables. And lastly, matrix in robotics. So they're useful to define more than one coordinate system, and they're useful for describing location of robotic hand. Matrices are really important in most of our calculations, like looking at electricity, math, even in some parts of science. So we do use the matrix a lot, and we will use it on further on in life. So that's it. That kind of wraps it up. This was just a beginning of the wonders of matrix. There's still so much that we could learn about this beautiful concept. We just touched a bit on adding, subtracting, the history behind it, which does continue on a lot, as many of the past mathematicians have used matrices and evolved it throughout time. And we also do use it in today's life. So thank you so much for listening, and I hope you learned a lot about the wonders of the Matrix.